So hello everyone, welcome back to my YouTube channel, your KGPN bro. So in today's video I am going to discuss about number line method to solve a given inequality. So here it is the steps. So let's say you are given a inequality, that means an expression containing any of these symbols. The symbols can be either greater than equal to, less than or equal to, greater than or less than. If a expression contains any of these symbols, then that will be a inequality. So how to solve that kind of inequality? So what are the steps? Let's see them. So first of all, you have to bring all the terms of the given inequality to left hand side. This is the step number 1, or this is the first task you have to do. You have to bring all the terms of the given inequality to left hand side. Then next step says convert LHS into a single fraction. So single fraction means something by something format. So you have to convert the LHS into a single fraction. Then in step number 3, we have to find out the critical points by putting numerator is equal to 0 and denominator is equal to 0. So we have to put numerator is equal to 0 and denominator is equal to 0 to find out the critical points. This is the third step. Then we have to draw a number line and we have to show all the critical points on that number line. Now you will get different intervals, and finally what you have to do? You have to pick out one arbitrary number from each interval and test whether that particular number satisfies the given inequality or not. This is the final step. You have to pick out one arbitrary number from each interval and you have to test whether that particular number satisfies the given inequality or not. So these are the steps to solve a given inequality. So let's see an example. So here it is an example, and the inequality is x upon x minus 2 greater than 3. So how to solve this kind of inequality? So it is the step number 1. So first of all, bring all the terms to LHS. Here one thing to be noted is that never cross multiply. So don't cross multiply this with 3 and then solve the linear inequality. So first of all, you have to bring all the terms to LHS. So here it is the inequality x upon x minus 2 greater than 3. So you have to bring this 3 to this side. So it will be x upon x minus 2 minus 3 greater than 0. Then in step number 2, we have to convert the LHS into a single fraction. Single fraction means something by something format. So it is x upon x minus 2 minus 3 greater than 0. So in order to convert this into a single fraction, we have to multiply this x minus 2 with this 3. So it will be x minus 3 into x minus 2 upon x minus 2 greater than 0. So it will be minus 2x plus 6 upon x minus 2 greater than 0. So this is the single fraction, that means something by something. Now in step number 3, we have to find out the critical points by putting numerator is equal to 0 and denominator is equal to 0. So here it is the numerator and this is the denominator. So you have to put both numerator is equal to 0 and denominator is equal to 0. So by putting numerator is equal to 0, so you will get minus 2x plus 3 is 6 is equal to 0. So you will get x is equal to plus 3. Similarly, putting denominator is equal to 0, so it will be x minus 2 is equal to 0. So x will be 2. So this x is equal to 3 and x is equal to 2 are the critical points. Then in next step, that means in step 4, we have to draw a number line. So here it is the number line and it goes from minus infinity to plus infinity. In next step, that means step number 5, so all the critical points on the number line. So this is the number line and 2 and 3 are the critical points. So now you will get different intervals. So these are the three intervals, one from minus infinity to 2, 2 to 3, and 3 to infinity. So these are the intervals. Now in step number 7, this is the important step. Pick out one arbitrary number from each interval and test whether that particular number satisfies the given inequality or not. So these are the three intervals, minus infinity to 2, 2 to 3, and 3 to plus infinity. We have to take one number from each interval and we have to put in this inequality whether that inequality satisfies or not. So for the interval 3 to infinity, I take a number that is, let's say, 4, and I put 4 in this inequality. So minus 2 into 4 plus 6 upon 4 minus 2 greater than 0. So it will be minus 1 greater than 0, and this is not correct. So this 4 does not satisfy the given inequality. So you have to put a cross over this interval. Similarly, we have to take one number from this interval, let's say 2.5, and we have to put over here. So now this number will satisfy this inequality. So we have to put a tick symbol about this interval. Similarly, we have to take one number from minus infinity to 2, and we have to check whether that particular number satisfies this given inequality or not. So this number will not satisfy this inequality, so you have to put a cross sign over here. So our final answer will be from 2 to 3. Thank you for watching this video.